everyone, welcome back to my channel. Today we are going to learn about very interesting data structure called StackQueue. We will see how we implement a queue using two stacks, explore the logic step by step, understand the two different methods to do this. Let's get started. Before we dive in, let's quickly recall what stacks and queues are. A stack follows LIFO, last in, first out, which means the last element you push on the top is the first one you pop. A queue, on other hand, follows FIFO, first in, first out, where the first element you insert is the first one to be removed. So the challenge is, how do we make a stack behave like a queue? That's exactly what we'll explore using two stacks, S1 and S2. Let's look at the first method of implementing a queue using two stacks S1 and S2. The main idea is simple. Whenever we insert or enqueue an element, we must ensure that the first inserted element always stays on top of S1. That way, when we pop from S1, it behaves like a queue. Removing element in the same order the first were added, first in, first out. We have two stacks, S1 and S2. Both are empty at the beginning. Let's start it by inserting the first element, 1. Since S1 is empty, we can simply push 1 onto S1. Next, we want to insert 2, but we can't just push it directly on top of S1 because then when we pop, 2 would come out first and that would break the queue rule. In a queue, 1 should come out first. So, here's what we do. Move element from S1 to S2. Now, push the new element 2 onto S1. Now, everything from S2 back to S1. Now 1 is still on top and 2 is below it. Perfect. Our queue order is safe. Let's continue with the same logic and insert the third element, 3. Move all elements from S1 to S2. Push 3 onto S1. Move elements back to S2 to S1. Now let's insert the fourth element, 4. Move all elements from S1 to S2. We have 1. Push 4 onto S1. Move everything back from S2 to S1. Now our S1 has all 4 elements in a queue order. 1, 2, 3, 4. The first insert element 1 is still on top, ready to be the queue first. Now, let's look at the second method of implementing a queue using two stacks. This one works in the opposite way compared to the first method. In the first method, the enqueue operation was a bit longer, but the queue was simple. Here, It's the other way around. NQ becomes easy and DQ takes a bit more time. In this second method, we simply push every new element directly onto S1 when we NQ. But when we want to DQ, we move all elements from S1 to S2, pop one element from S2, and then move everything back to S1. That way, the first inserted element comes out first, maintaining the FIFO behavior of a queue. Let's start by inserting 1. Since S1 is empty, just push 1 onto S1. Now insert 2 again. Just put it directly onto S1. No rearranging this time. Insert 3, simply push onto S1. Insert 4, same thing, push onto S1. Now our S1 stack contains all 4 elements in order of insertion. But remember, it is stack. The last one element 4 is on the top. So we can't directly pop it for a queue because we need to remove 1 first. Let's now perform the DQ operation and see how it works. To DQ, move all elements from S1 to S2 one by one. Move 4, move 3, move 2, move 1. Now, the top of S2 is 1, which was the first inserted element. Perfect. Pop it from S2. That's our first DQ result, 1. Let's DQ once more. Move everything from S1 to S2 again. Pop the top of S2, that's 2, output 2. Now, move everything back to S1. Repeat the same process. Move all elements from S1 to S2. Pop from S2, that's 3, output 3. Now we only have one element left in S1, which is 4. Move it to S2, pop it, and we get output 4. Now both stacks are empty. If we try to DQ again, we simply return -1, meaning the queue is empty. In this second method, the NQ operation is very fast, just one push. But the DQ operation takes more time because we have to transfer element between stacks each time we remove something. So, to recap, method 1, slow NQ, fast DQ. Method 2, fast NQ, slow DQ. Both achieve the same results, a queue using 2 stacks. Let's explain the code for the first method. We have a class called queue using 2 stacks 1. Inside it, there are 2 stacks S1 and S2. Now look at the enqueue method. When we want to insert a new element, we first move all elements from S1 to S2. This clears space in S1. Then we push the new element into S1. After that, we move everything back from S2 to S1. By doing this, the first inserted element always stays at the top of S1. So, when we remove, we just pop from S1 and it will follow the first in, first out rule of a queue. In the DQ method, If S1 is empty, that means the queue is empty. So we return -1. Otherwise, we pop the top element and return it. So in this approach, enqueue takes more time because we have to move all elements twice. But dequeue is very fast, just a single pop. Now let's explain the second method. Here, the class is queue using two stacks too. And again we have two stacks, S1 and S2. In this method, the enqueue function is very simple. We just push the new element directly into S1. The dequeue function is where the main work happens. First, we check if S1 is empty. If it is, the queue is empty, so we return -1. If not, we move all elements from S1 to S2. They reverse their order, and now the first inserted element comes to the top of S2. We pop one element from S2, that's our front element of the queue. When we move the remaining elements back from S2 to S1 to reverse the original order. So this method makes enqueue very quick, but dequeue becoming bit closely because of all these movements. Let's look at a real-life example of a stack queue. Imagine a customer service desk. People take tickets and wait to be served. The first person who arrives should be helped first, just like a queue. Internally, the system might store tickets in a stack, but it rearranges them so that the first person stays on top. When serving a customer, the system just takes a top ticket, which is the first person who arrived. This is exactly how a stack queue works. It uses two stacks to make sure elements are removed in first out, just like a real queue. So that's how we can implement the queue using two stacks. We learned two different methods. In the first one, enqueue is costly but dequeue is simple. And the second one, enqueue is simple but dequeue is costly. Both give us the same results. Elements are removed in, first out, just like a real queue. I hope this explanation helped you understand the logic clearly. If you found this video helpful, don't forget to like, share and subscribe to my channel, more data structure and algorithm videos. Thank you for watching. See you in the next video.